The other thing where we need to be confident, in addition to interpreting the slope and y-intercept, writing those nice sentences, is making predictions, using that equation to answer questions about the real world. So let's stick with the computer repairman example once again, where we know b is equal to 20h plus 60. Now before you even go read these questions, I think it's important to write down your equation and label what is h and what is b. So if we go back to the word problem once again, it says the total bill b and the number of hours worked h. So I'm going to know that over here b is the total bill that the computer repairman is going to charge, bill, and h will be the number of hours worked. Before you make a prediction, it's really going to make your life easier if you label the variables. Now we can go to the problem. Number 7. How many hours did he work if he made $160? So I'm going to write down the number from the word problem and the idea. That 160 is counting money. Not pennies, not puppies, not rainbows, but money. So now when I go up to my labeled equation, which variable matches money? Well, this isn't counting hours, but a bill is the same idea as money. So I'm going to go and replace that variable with the idea of 160. And now I have a little equation to solve to see how many hours it takes for him to make that money. Now remember, we want to solve for h. We have a closer friend and a far away friend. We're always going to save the closer number till the end. We're going to use our inverse of subtracting 60 to get 100 equals 20h. When there's nothing in between the number and the letter, that's multiplication. So the opposite is division. And we would need to work 5 hours in order to get $160. So number 8, how much will he make if he has to work for 11.5 hours? So I'm going to write down the number and I'm going to write down the idea. Once again, that was 11.5 hours. And now I ask myself, does that number match h or b? Well, obviously this is hours and we labeled that as hours. So we're going to swap out for h. When I swap out like that, instead of the letter h, I'm going to make a nice big parentheses to then put the 11.5. PEMDAS has us multiply before we add. 20 times 11.5 is 230, plus 60, $290 after 11.5 hours. One more example. A trucking company charges $2 per mile for delivery, plus a $40 flat fee for the driver's expenses. Write an equation that will model the total cost of delivery and the number of miles. So we have C equals 2x plus 40. C equals 2x plus 40. Oops. So before we do anything, we have to label our variables. So I go back over here and it says the total cost of the delivery, C. So I know C is the cost of the delivery. And the number of miles driven. So X will be how many miles that guy is going. The predictions. The one over here. How many miles were traveled if the total cost of the delivery was $85? So I'm going to take the number from my word problem, $85, and I'm going to make sure I know what idea it is. Because then ask yourself, does this number match miles or a cost of delivery? And money matches a cost. So I'm going to plug in that 85 up for the C instead. I'm going to come over here to have some more space. Since the 85 represented a money amount, I plugged it in for C, and that's why you only see the 85 here. Now we have a little equation to solve for X. We save the close number till the end, we get away with the far away number using our inverse operations. 2x is multiplication, so the opposite is division. And x will be 22.5. 22.5 miles for a delivery of $85. 31 miles. So I'm going to go take the 31 and label it as miles. And now I'm gonna ask myself, does that number match my X or my C? I labeled X as miles, so we'll plug that 31 in for X. And like I said, when we plug in, we're gonna use parentheses. Instead of X, I made a set of parentheses, so now that 31 has a nice organized space. 2 times 31 will get us 62. The cost will be $102 if it was a 31-mile delivery.